guys, today we're going to talk about rational numbers, and this goes with the learning goal, I can compare and order fractions and rational numbers. So you're probably asking yourself right now, what is a rational number? I've never heard of such a thing before. Is it a number that's not insane? Well, not exactly. A rational number is a number that can be written as the quotient of two integers where the divisor is not 0. Wow, I bet that cleared everything up for you. Basically, what you need to know is a rational number is any number that can be written as a fraction, where you have an integer, meaning a positive or negative number that's not a decimal or a fraction. So you've got like a whole number that can be either positive or negative over another whole number that's either positive or negative, but the bottom number can't be 0. You can't divide by 0 in math. It's just not allowed.
Seriously? It's not that complicated. If you can write it as a fraction, it's a rational number. Bye!
When we want to compare rational numbers of different forms, so if I have a fraction and a decimal, or two fractions with different denominators or something like that, it's easiest to change them so that they are all in the same form, and that makes them easier to compare. So we're going to talk about what that looks like. So if I want to compare -1/2 and -3/4, I can think about where those numbers would fall on a number line. That's one way to compare them. So here's my number line, and if I just go ahead and say that this is 0 in the middle, then everything going to the right of 0 is going to be positive. So these are where the numbers get larger and larger as you go to the right, and they're all going to be positive. And then going to the left of 0, everything is going to be negative. And the further you go to the left on the number line, the smaller the numbers get. And that's a rule whether you're to the left or to the right of 0. The further to the left you go, the smaller the number is. The further to the right you go, the larger the number is. Now, when we're talking about positive numbers, the further away from 0 we get, the larger the number is. But you can see over here on the left-hand side, to the left of 0, the further away you get from 0, the smaller the number is. So negative numbers, when we're working on comparing them, are kind of backwards from positive numbers. So let's go ahead and think about my number line right here. If I was counting by fourths on my number line, the first 1/4 I would come to would be -1/4, moving to the left of 0. And then I would have -2/4. And then I would have -3/4. And then I would have -4/4, which is the same as -1. So I could keep counting along in that direction, counting by fourths if I wanted to. And the reason I'm counting by fourths on my number line is because I have that number -3/4, and I also know that I can change -1/2 into fourths. And I'll be able to graph these on my number line. So if I look, -3/4 is going to be right here on my number line. And -1/2, if I change that into fourths, I would need to multiply my numerator and my denominator both by 2, and I would still have a negative, and I would have -2/4. Because here I've multiplied a negative times a positive, and a negative times a positive is negative, so I have -2/4, and I could graph that on my number line right here. And now I can see that -3/4 is actually going to be smaller than -1/2 because it's further away from 0. It's to the left of -1/2 on the number line. And so both of those things tell me that -3/4 is smaller than -1/2, which isn't true if I'm talking about positive numbers. Negative numbers kind of work in the reverse of positive numbers when I'm thinking about comparing them. So I could write a statement here, which I could say that -1/2 is larger than -3/4. So I could use the greater than symbol and to show the comparison there that -1/2 is greater than -3/4. Now if I want to compare decimals, I need to look at the place values of those decimals and make sure I'm comparing the same place value. Now these two numbers here, -4 and 4/10, and then also 4 7/10 are very easy to compare. Any negative number is always smaller than a positive number. So I can just say right off the bat that negative 4.4 is less than 4.7. I don't even really have to think about it because one of them is negative and the other one's positive, so the negative one has to be smaller. Now, when I'm talking about two negative numbers, now I have to actually look at their different place values and figure out which one, how they compare to each other, because I can't just say, well, one's negative and one's positive. So now, if I was talking about positive numbers, I would know that 4.2 is less than 4.9. It has, if they both have a 4 in the ones place, but 2 is smaller than 9, and those are both in the tenths place. So I could see that 4.2 would be smaller than 4.9. However, these are negative numbers, so this is going to be the reverse. Negative 4.2 is closer to 0, further to the right on the number line, and therefore it's actually larger since I'm talking about negative numbers. So I would write negative 4.2 is greater than negative 4.9. Now here's a list of numbers where some of them are fractions and some of them are decimals. They're all rational numbers because they all could be written as fractions if we wanted to. I could rewrite all of these numbers as fractions, or I could rewrite all of these numbers as decimals. And anytime we have a list where they're mixed together like this, it's a good idea to either change them all to fractions and then change those fractions so that they have the same denominator, or I could change all of my fractions to decimals. And we learned how to do that in the last lesson. Remember that to change a fraction to a decimal, you just take the numerator and divide that by the denominator, because the fraction bar means division. It's a symbol for division. So I think what I'm going to do is go ahead and change all of these fractions to decimals, because that way I don't have to also worry about finding a similar denominator. So I know that 1/4 is the same as 0.25. However, if I did not know that, I could grab my calculator and I could do 1 divided by 4, and that would give me 0.25, and I could see that right there. Negative 0.2 is already written as a decimal, so I don't need to do anything about that. I also know what negative 2/9 is as a decimal, because I know that if you have ninths in the denominator, then your numerator just repeats over and over. So 2/9 is the same as 0.2 repeating. And again, we could show that on a calculator if we didn't know. I would do 2 divided by 9. And that gives me the 2 repeating over and over and over again. And then the last number is also already written as a decimal, so I can just write that again as 1.1. So now I need to look at these. I know that my negative numbers are smaller than my positive numbers, and there are 2 negative numbers, so I'm going to look at those first. Negative 0.2 and negative 0.2 repeating. That's kind of tricky. However, if you think about it, negative 0.2, I can put as many zeros as I want after a decimal without changing the value of it. So those zeros actually repeat forever. Negative 0.2 repeating is the same as 0.2222, and that too keeps repeating. So if I look at it that way, they both have a 0 in the ones place, they both have a 2 in the tenths place, but after that, 0.2 has zeros in all the place values, and 0.2 repeating has 2's in all the place values. So if I was thinking of these as positive numbers, 0.2 repeating would be bigger. However, these are negative numbers, so it's backwards. So negative 0.2 repeating, or negative 2/9, is going to be the furthest away from 0, or the smallest number. So that's my very smallest. Then I have negative 0.2. Now I need to look at my positive numbers. I have 0.25 and I have 1.1. Well, 1.1 has a 1 in the ones place, whereas 0.25 has a 0 in the ones place. 1/4 is always going to be smaller than 1 and something else. So 1/4 is my next smallest number, and then my largest number is 1.1. So I have now put those in order from smallest to largest. Here are your free response and multiple choice question. There are only 3 choices for the multiple choice question today, so go ahead and pause the video and answer those questions now.